Hi everyone, and welcome to this tutorial bite for Oxygen Not Included, where we're looking at solid material shipping. This is actually not a difficult topic, and is really very similar to gas and liquid piping, but it's unlocked further down the tech and skill tree, and has different mechanics for loading and unloading the rails, which makes it seem less accessible. In this video, I'm going to explain the mechanics of conveyor rails and how to load and unload them, then show some common examples. So let's start at the beginning and how to load conveyor rails, which is done with the conveyor loader. It consumes 120 watts of power when loading materials and is the equivalent of a gas or liquid pump. Note that it does not need to be on a floor and can be placed in the air. They can also be rotated. This must be built by a dupe with the mechatronics engineering skill, like all of the shipping buildings, so make sure to have a couple of engineers in your base. The main difference versus gas and liquid pumps is that it needs to be loaded with specific materials. Clicking on the loader shows the material filters, which are much like a storage bin. Obviously choose the materials you want to send, and you can choose sweep only to only load materials with a sweep command. There are two methods of actually loading these, and the simplest is to use dupes. To do this, tick allow manual use, and dupes will load it like a storage bin. Beware that with this option, it's possible to make an infinite loop, wasting dupes time. So if manually loading, ensure that this is sweep only or that the output is not accessible. The other method is to use an Autosweeper. This also consumes 120 watts when moving material and has a 9x9 tile range, itself being 3x1 tiles even though it looks bigger. They do not need to be placed on a wall or floor and can also be rotated. It is a static building, and this limits where you can really benefit from using solid shipping systems. The best situations are where resources are being produced in a fixed place and need to be moved to another. Autosweepers work on the task priority system, and they will move material to or from any building with storage. This allows automated collection and transport, as well as the supply of key buildings, for example, electric grills. As a tip, Autosweepers can reach through diagonal corners, whereas dupes now cannot. So having covered how to get materials onto the rails, I'll now touch briefly on rail mechanics. Rails carry solid debris in 20 kg packets, and follow exactly the same mechanics as liquid and gas pipes. Hopefully, all the buildings are familiar. Bridges can be used for prioritising rails in the same way, and as I covered all of these interactions in the tutorial bite for pipes, I won't go into further detail. I'm showing here the conveyor bridge, conveyor shutoff and solid filter, which work exactly the same as their gas and liquid counterparts. Rails also have an interesting behaviour in significantly improving heat conduction for materials on them. To demonstrate this, here's an example of 1 ton of ice debris in a pool of warm water. Debris is very poor at conducting heat, so this will take quite a while to melt, even with the temperature difference. Compare this to loading it on a conveyor rail and creating a closed loop, as I've done here on the right, and it's clear that the ice will melt much faster. Therefore, this idea is commonly used in builds to efficiently extract heat from hot debris. Getting material off the rails is done by one of two methods, either the conveyor receptacle or chute. The receptacle is the more controlled way, and will become full if not emptied, jamming the incoming rail. This is most useful in applications where only limited amounts of material are needed, or you want to split material between different areas. Like the loader, they also do not need a floor and can be rotated. On the other hand, the conveyor chute simply empties any incoming material onto the floor, much like the liquid or gas output vents. In contrast to the receptacle, chutes are best used when all the material from a conveyor system are going to the same place. And that really is everything to know about how solid shipping works. So now let's look at some example uses. Firstly, this is a large wild farm, and the food is collected by sweepers and loaded onto the loaders to head towards the kitchen. Of course, this setup would also work with a domestic farm, and the plants can be closer together. Autosweepers can also be used to automate fertilising the plants. The rails all join together and head off to supply the kitchen. Here in the kitchen, the food is dropped onto the floor using the chute, and is then supplied to the microbe mushers, electric grills and gas ranges by the Autosweepers as well. Once the final food, frost burgers, are completed, they are then loaded onto another loader and sent up to the food storage in the base. Another common use is in metal volcano taming to get the metal out automatically. This will require steel to avoid overheating, but the idea is relatively simple. To close off the room, we can use an autosweeper inside that loads the refined metal onto a rail. The rail circulates around the room, transferring heat, and once cool enough is brought outside. This then runs against the cooling loop behind the steam turbine, taking advantage of the heat transfer to cool it further. The cooled metal is then output into a pile for collection. And the last example to look at is the nuclear reactor. These need to be fed enriched uranium as fuel, and is obviously a dangerous environment for dupes. To automate this supply, an autosweeper can be used, again made from steel inside the steam room. Enriched uranium is then manually supplied to a loader and dropped nearby. And so that's all for this guide to solid material shipping in oxygen not included. I hope this helps you efficiently move solids around, and thanks for watching.